All right, Rochelle. I'm not entirely sure I'm doing this the way your instructor would have you do it. But I'm just going to do the question. I'm putting it in night mode. There we go. Okay. That is better. Okay. The basic idea is we've got this sinusoidal function. As I understand it, it's going to go as high as 8 and as low as 1. And it has a cycle of roughly 12 minutes, right? This is what we're told. And so it's going to go like that, basically. And obviously, the function goes on and on. Okay. And we want to know when it is above 3, because that's when it's safe to dive. And so it's going to be safe to dive and specifically, sorry, I just have to recheck the question to see when during the daylight hours would it be safe to dive off the dock. So that's interesting. So the daylight hours are going to be, when does this start? Well, I'm not sure about the daytime hours thing. That's kind of weird to me. Like, is this midnight or is this noon or is this? I don't know. We'll get to that. Anyway, it's a repeated cycle. So once you've got the answer, figuring out what daylight looks like is really up to you. But the basic idea is this, that we need to say, we want to know at what times, and this is exactly what you said, that we want to set the height to 3 meters. So we can say 3 equals 3.5 times the cosine of pi over 6 times t plus 4.5. All right, so there we are. And now we just want to solve this, and it's really not so bad. First, we're going to subtract 4.5 from each side, and we'll get negative 1.5 equals 3.5 times the cosine of pi over 6. By the way, I encourage you at every stage to pause this and see if you can figure out the next step, and see if you can get all the way, and only press play if you feel like you get stuck. Anyway, I'm going to kind of move quickly here. But eventually, we want to solve for this t. So we've got to get t by itself. And the next step is going to be to divide this side by 3.5. And what we do to one side, we must do to the other. Now, I hate this fraction. You could work with this fraction, but I really hate this fraction. And because they're both 0.5s, I kind of see that if we multiply the top and the bottom of the fraction by 2, we'll end up with a nice whole fraction. So I'm going to call this actually negative 3 over 7. This is not a necessary step, but it helps me understand this. Now, because it's a periodic function, we always recommend you work with the related acute angle. So keep in mind that to get rid of this cos, we're going to do the cos inverse. All right, so we're going to take the cos inverse of this side and the cos inverse of that side. And because we're taking the cos inverse, here it's just going to cancel the cosine. That'll leave us with pi over 6 times t. But here we're actually taking the cos inverse of this number. Now keep in mind this number is negative. So if we look at the cast rule, we know that here, cosine and all of them are positive. So that doesn't work for us, actually. So our solutions are going to be in this side. But I'm going to use the related acute angle, which is just to say I'm going to ignore that negative sign, because the negative sign is going to give me a solution up in this quadrant, and it'll give me the angle like that. But it'll actually make finding the second angle that's down here a bit more of a pain in the butt. I mean, it's not a big deal. You could just do it as 2 pi minus that. But as a rule of thumb, we usually use the related acute angle. I'm going to take the cos inverse of 3 over 7. I'm just going to use my calculator to do that. And this will not be an exact number. All right, you can't get an exact number for this one because negative 3 over 7 or 3 over 7 is not one of your special triangles, unless I'm missing something. So we've just got to do that. And when we take the cos inverse of 3 over 7, we get 1.1279. And keep in mind that we're talking about angles here. So this is going to be pi minus that. And this is going to be pi plus that. Which means we're going to get two solutions over here in a single rotation, in a single revolution. And I'm going to do the math actually on both of these. I'm just going to give myself two solutions to work with. And over here, I'm going to say, now what is pi minus 1.1279? I'm just going to do that over here, pi minus 1.1279. And that gives me 2.014 equals pi over 6 times t. All right, that is pi minus 1.1279. And over here, I'm going to do pi plus 1.1279. And that is going to give me 4.269. And still, that's going to be equal to pi over 6 times t. Now remember, this 2.014 and this 4.269 tells you in a normal 2 pi revolution where these zeros lie. But of course, we want it for this more complex solution here, and that's what this additional calculation is going to do. And so now t is just going to be equal to, well, we're going to multiply both sides by 6 to get rid of the 6. And then we have to divide by pi to get rid of the pi. Over here, we're going to multiply by 6 over pi as well. And our answer is going to be t equals 2.014 times 6 over pi. And we can just do that really quickly over here. 2.014 times 6 divided by pi. And we get 3.846. Is this hours? I believe this is hours, yeah. And we'll do the same thing over here, where to get t by itself, we have to multiply this by 6, and then divide it by pi. And what we do to one side, we must, of course, do to the other. And we end up with t being equal to 4.269 times 6 over pi. And I'll do that over here. And the result is 8.153. Now, what this tells us is this exactly. If we go back to our original drawing of this thing, this being 1, this being 8, what it tells us is that at 3.84, we hit 3, and we actually drop below it. And then again, at 8.153, we hit it again. And of course, again, because this one cycles out to 12, here, this next cycle will be at 3.84 more than 12, which is 15.84. And then this will be at 8.153 more than 12, which would be 20.153. And so on and so forth. That should be 18 seconds, that should be 24. And we could, of course, keep going. But I think that this gives us a sense. This means that the workable solution here, this area from 0 to 3.84 is above this area from 8 to 15 is above, and we drop below again. And this area beyond 20 is above, and then that's a full one-day cycle. Now, if we assume, because we're not actually told this directly, but if we assume that this is midnight, well, that would make 12 noon. This would make 24 the next midnight. And if we're talking about daylight hours, then this is the working solution set right here. So the working solution would be where t is greater than or equal to 8.153 and less than or equal to 15.84. And if you were really, really finicky, you could say, well, 0.153 times 60 minutes, because there's 60 minutes an hour. 0.153 times 60 is 9. So this could be from 8:09 in the morning to, and then that'd be AM. And then 1500 hours is 3 p.m. And we can figure out what 0.84 times 60 is. And that would be 50. So if we assume that T is time in hours after midnight, you know, like kind of the 24-hour clock system, then from 8:09 a.m. to 3:50 p.m., the tide is above 3 meters, or feet, or whatever the heck it's measured in. Meters. There you go. And is what? And is safe to dive. So I hope that helps. As a follow-through, let me just walk you through it again because it's a little tricky. But you have to take the equation, and like you said, you have to set it equal to 3. And setting it equal to 3 is going to tell you when this is at 3 exactly. And keep in mind that in a single cycle, we would expect that to happen twice. Once as it drops down below 3, and another time as it rises above 3. We're going to see that twice. And that makes sense because we're going to take the cosine of a number, and of course when we take the cosine of a number, it's going to give us 2 solutions. So we want to get the cosine of pi over 6 times t all by itself on this side. So first we subtract 4.5 from each side, gives us negative 1.5. We divide both sides by 3.5. You could work with this fraction. I just hate decimals in a fraction. I think it's clunky and awkward. So I just double the top and bottom here, because in this case, that gives me negative 3 over 7. I chose to use the related acute angle because in my mind, that is kind of an easy thing to think my way through. And we ended up with a related acute angle of 1.1279. And I might even show that on here in green. But this is the related acute angle. 1.1279. And then what we basically say is, okay, well, the actual angles we're looking for is -3/7. Well, cosine is negative where? Cosine is negative in quadrants 2 and 3. So I'm going to take that related acute angle up into quadrant 2 and take that related acute angle down into quadrant 3, and I'm going to get two solutions. So one of these is going to be pi minus the related acute angle. One of them is going to be pi plus the related acute angle. And so I do that here. Pi minus the related acute angle is 2.014, and I'm putting that in here. So that's equal to pi over 6 times t. Remember, when I took the cos inverse of each side, now this is no longer the cosine of pi over 6 times t, it's just pi over 6 times t. And now it's just a matter of simple arithmetic, right? I'm going to times by 6 and divide by pi on both sides to isolate the t. We get t is equal to 2.014 times 6 over pi. And that works out to 3.846 hours. And over here we're doing the same thing, but this time with the second angle, the angle of 1.1279 plus pi, which is 4.269. And in this case, again, we're going to multiply by 6 over pi. Isolate t, we get t is equal to 4.269 times 6 over pi. That gives us a time of 8.153 hours. And if I sketch that out, we're looking for times when the water is deeper than that, right? So we want deep water. So we want the water when it is deeper than 3 meters. And if we assume that t equals 0 is midnight, then from midnight to 3 a.m., almost 4 a.m., it's above 3 meters, but it says daylight hours, and midnight to 3 a.m. is not daylight hours. We're going to ignore that as a solution. Then from 3 a.m. to 8 a.m., the tide is too low, and you wouldn't want to dive because it's below 3 meters. Then from 8 a.m. to 3 p.m., almost 4 p.m., the water is again safe. And then from 4 p.m. to 8 p.m., the tide is too low. And then from 8 p.m. until, as we know, 3 a.m. the next morning, the tide is high enough, but that's not daylight hours. So it's just this middle section here that we like. And then because I'm like that, you know, just my commitment to excellence, I said, well, wait a minute. You know, we don't talk about time as 8.153. So I took that 0.153 and I said, well, there's 60 minutes in an hour. That actually leads to this being 9 minutes. And here I said, well, 0.84, again, we don't talk about hours that way. But there's 60 minutes in an hour, so 0.84 times 60 should yield us 50 minutes. And so from that, we can know from 8:09 a.m. to 3:50 p.m., the tide's above 3 meters and it's safe to dive in. But I hope that helps, and yeah, ciao.